The Pendulum Lab. Introduction. Objectives. To measure the potential energy and kinetic energy of a simple pendulum. To determine whether the energy is conserved using a simple pendulum. Procedure.
We conduct the simple pendulum experiment by using PhET simulation. First, adjust the length of the pendulum to 0.6 meters. The weight of the mass to 1 kilogram. Then, click on the ruler from Tools Options to use the ruler to measure the height of the mass. We measured the height of the weight in 3 positions. Position A is the highest point at left-hand side. Position B is the lowest point. Position C is the highest point at right-hand side. Then, we measure and record the height of position B. And set the angle of the pendulum to 30 degrees. Then, adjust the speed of the oscillations to slow, to facilitate the measuring of the height of position A and C. Next, click on play icon to let the mass oscillates. At the highest point, we pause the oscillation to measure and record the height of position A, then we measure for position C. We take note the shape of the energy graph during the oscillation at position A, B and C. The steps is repeated with the angle 40 degrees and we observe the energy graph. Same goes to when angle at 50 degrees. We then calculate the total energy, potential energy and kinetic energy.
Results. Table 1 shows the results of pendulum at 30 degrees. The height of the mass for position A, B and C are 0.4 meters, 0.34 meters and 0.4 meters respectively. Calculation for position A. The formula for potential energy is mgh. Mass is equal to 1 kilogram. Times gravitational acceleration equal to 9.81 meters per second square. Times height of the mass which equal to 0.4 meters. Therefore the potential energy is equal to 3.924 joules. At position A, the kinetic energy is equal to 0 joules. Therefore the total energy, equal to potential energy plus kinetic energy, where potential energy is equal to 3.924 joules, plus kinetic energy is 0 joules. Therefore, the total energy is equal to 3.924 joules. Since the energy is conserved, therefore the total energy is same. For position B, the formula for potential energy is mgh. Mass is equal to 1 kilogram. Times gravitational acceleration equal to 9.81 meters per second square. Times height of the mass which is 0.34 meters. Therefore, the potential energy is equal to 3.335 joules. Since the total energy is equal to potential energy plus kinetic energy. Therefore, kinetic energy is equal to total energy minus potential energy, where total energy is equal to 3.924 joules. minus potential energy which equal to 3.335 joules. Therefore, the kinetic energy is equal to 0.589 joules. For position C, the formula for potential energy is mgh. Mass is equal to 1 kilogram times gravitational acceleration equal to 9.81 meters per second square times height of the mass which equal to 0.4 meters. Therefore the potential energy is equal to 3.924 joules. Since the total energy is equal to potential energy plus kinetic energy, therefore, kinetic energy is equal to total energy minus potential energy, where total energy is equal to 3.924 joules minus potential energy which is 3.924 joules. Therefore, the kinetic energy is equal to 0 joules. For Table 2 and 3 for the results of pendulum at 40 degrees and 50 degrees respectively are calculate using the same formula. Table 1 results of pendulum at 30 degree. Table 2 results of pendulum at 40 degree. Table 3 results of pendulum at 50 degree. Discussion.
Based on the graph, at position B the energy of the system is in kinetic energy.
When the pendulum swings upward, position A, kinetic energy convert into potential energy. When the pendulum stop at A, the kinetic energy is 0 and all the energy of the system is potential energy. When the pendulum swing back to position B, the potential energy is converted back to kinetic energy. When the pendulum swing upward again to position C, kinetic energy is converted to potential energy and kinetic energy becomes 0. These will be discussed and learned in Chapter 5 Work and Energy in Subject Mechanics, SFT 3033. If the total energy which is potential energy plus kinetic energy neither increases nor decreases, then total energy of a mechanical system is conserved. Conclusion. Law of conservation of energy is the total energy that's same as the initial potential energy, which means the energy is conserved.
Thank you.